Welcome to this video. So in this video, we are going to revise test 1. This is for student at DISCRETE Medical Apex University, okay? But if you're at any other university, feel free to watch the video because the concepts are just the same. Okay, so we have 3 questions in this video. I'm going to solve all of them, okay? So if you have any questions, feel free to contact me. All right, so we start from question 1 there. Right, so question 1, they're saying, write the set, okay, and then they've given us this set, which is in set builder notation, okay. They're saying we write this set in roster form, okay. So roster form, it means we want to write this set in a way where we are listing all the elements that are contained in that set of, okay. The way it's given there is just a description. Then we want to convert it into a roster form where we are listing all the elements in that set. Okay, so they're saying AN, okay, is a set of all ANs such that, okay, this AN plus 1 is equals to 2AN plus 1, okay, where this AN is equals to what? This A1, I mean, is equals to 2. And then they're saying this N is a member of the natural numbers such that this N is less than or equal to 2. So we know that natural numbers are numbers that we call as counting numbers. So they start from 1, 2, 3, 4, all the way unto what? Positive infinity. These are what? Natural numbers. Okay, so here they're saying this N is a natural number, but it is less than or equal to 6. So it means the values of N that we are going to use here, just 1, 2, 3, 4, 5, and 6. These are the only ones that we're going to use because we have been given a restriction there. Okay. And then they're saying, okay, this set is a set of all these ANs, okay, such that N plus 1, okay, is equals to 2 AN and then plus what? 1. Okay, so we've been given the first one here. We've been told that A1, okay, if we get the 1 there, okay, we've been told that A1 is just going to be equals to 2. Okay, so what if we want to find A2 for this one here? What are we going to do? Okay, so A2 is equals to, I'll follow this formula here. Okay, so A2 is the same as A1 plus 1. Okay, and then is equals to 2a, okay? So here there's n, even there's n, right? Okay, so it means the number that we put here for n is the one that we should put here for n, because this is n, even there is n, right? Okay, so I'll write a 1 there, okay, and then plus 1. Okay, so this will be equals to, our a2 will be equals to, okay, this part here. So it will be 2 multiplied by a1. We know that a1 is 2, and then plus 1. Okay, so this will just be 4 plus 1, which will give us what? 5. So it means that my A2, we found it is what? 5. Okay, let's find our A3. So we are still using the same formula. So we're going to say A3 is equals to, so I'll write this 3 in terms of something like this. So I'm going to say A2 plus 1. Okay, so it means my N here is now 2 is equals to 2 AN, okay, but this AN is now 2 and then plus 1. So this is going to be equals to 2. What is our 2A? I mean our A2. Okay, our A2 is just 5, and then plus 1. So this will be 10 plus 1. So this will just be 11. So it means my A3 will just be what? 11. Okay, what about my A4? Okay, I'll say A4, I'll write it in terms of this. It will just be A3 plus 1. So make sure that here we just have a plus 1. Okay, so whatever number is there, make sure you express it as a plus 1. Okay, so there it means that, okay, there it means that this 3 is now my n. So this will be equals to 2 an, but the n is now 3 and then plus 1. So this is going to be equals to 2. What is my A3? A3 is what? 11 and then plus 1. So this will be 22 plus 1. That will just be what? 23. So I'm going to say A4 is equals to 23. So we're just remaining with the A5 and A6. Okay, so for those, we can also do this. Okay, so I'll just erase this. So if I erase this, I erase that, Okay, I erase that, and then I also erase whatever I have here, and I erase that. Okay, so there now we are finding A5. So A5, you express it as something plus 1, it will just be 4 plus 1. So it means the AN here is now 4. Okay, so what is our A4 that I'll put inside here? It is 23, and then plus 1. So 2 multiplied by 23, that will be 46, and then plus this one to be 47. Okay, so it means my A5 will just be 47. So we're just remaining with A6 now. Okay, just remaining with A6. So let's erase this again, and then we find our A6. Okay, so it means our A6 will just be 5 plus 1 here. So it means my N is 5, so I'll put 5 there. And then what is my A5? It is 47. So 2 multiplied by 47 plus 1, okay, you're going to get 95. So it means my A6 is just what? 95. So we found all our elements that are supposed to be in that set. Okay, so now we can write it in what? Roster form. So we're going to say the set A is just going to be equals to, okay, 2 is the first one, and then we have 5, then we have 11, then we have a 23, okay, and then 47, and then 95. Okay, so this set that we had on A, when we write it in roster form, to just be what? This set here. Right, so that's how you answer A. And then B, okay, it will be the opposite of what we are doing here. Okay, so I encourage you to pause the video and then you try it out on your own and then compare with my answer. So B, we've been given, okay, this set. So 2 over 3, 3 over 4, 4 over 5, 5 over 6, and then 7 over 8. So this set here is in roster form. And then they're asking us to change it into what? Set builder notation. So they want us to change it to a form where we'll just be describing the elements that will be found in this set, but not actually what? Listing them. So you identify the pattern there. You see that on top there, these numerators are just increasing by 1. This is 2, 3, 4, 5, 6. I mean, did I miss 1 here? Yeah, I missed 1 here. Okay, I missed the 1 for 6 over 7. So it should be 6 over 7 and then 7 over 8. Yeah, so I missed 1. So you notice that on top here you have 2, 3, 4, 5, 6, 7. They're just increasing by 1. Even down here, they're starting from 3 and then they're increasing by 1. Okay, but when you look at the relationship between just this one term, we see that whatever is on top increases by 1 when you go to the denominator. Whatever is on top increases by 1. Whatever is on top increases by 1. Whatever is on top increases by 1. Okay, so we'll say our set B, okay, will just be the set of all ANs, okay, such that we can say AN, okay, is equals to N divided by N plus 1. Okay, that's what we can see here. If I have a number there in the denominator, I'm just increasing it by 1. No wonder I've written N and then N plus what? 1. Okay, and then from there now we have to limit these ends here so that this makes sense. So we see that all these are natural numbers, right? Okay, all those are natural numbers. So what are we going to do there? We're going to say, okay, we're going to say comma, N should be a natural number, okay? And this N, okay, should be between 2 and 7. Okay, if your N is between 2 and 7, then this is going to be satisfied because the numbers that we use there will be 2, 3, 4, 5. Okay, I don't know why I'm writing 7, 6, and then 7. So if you want to find the first element in this set and then you use this formula, okay, it's going to be what? It's going to be N2 because here we have said these N's are starting at 2. They're not starting at 1. So you're not going to have A1. No, you're just going to have A2 to be the first element there. You're going to say A2 will just be equals to, where there's N, we put 2. Okay, and then down there, there's N again, you put 2 and then plus 1. So the first element will just be 2 over 3. That's what you can see here. So this here, okay, describes the sets that we have there perfectly in in a set builder notation. Okay, so some people, they may not write the AN here. Okay, instead they can just put X. So they'll say set B is a set of all X's such that this X is equals to this. Okay, this is still true and it's still correct. So if you want, you can use X there, or you can use the AN. There's no problem. Okay, as long as you show the restrictions there. Right, so we are done with question A. Okay, what about question B? Question B, they're saying write down the power set of set J. So set J has been given like this. Okay, this is my set J. And then they're asking me to write the power set. So what is the power set? Okay, so the power set is a set that contains all the subsets of a given set. Okay, so if, for example, I had another set here, A, which had 1 and 2. Okay, so the power set of set A will just be this set. It will contain all the subsets from here. So the subset from here can have 1 is the subset. Okay, so it is a set that contains sets. That's the power set. Okay, so this is the subset. I'll write it there. 2 is a subset. I'll write it there. The set itself is a subset. Okay, always the set itself is a subset, and then even the empty set there is always a what? A subset. So this here will be the power set of this set A. So that's what we are going to do here. Okay, the subset of this set, it can be one alone, 2 alone, or this set alone. Okay, or we can combine 1 and 2, can combine 1 and this. Okay, we can combine 2 and this. Those will be the subsets of this set. And then we just list them in a set. That will be the power set. So I'll say power set of J, okay, is equals to, the first set I'll just write 1 alone, then 2 alone, okay, and then this set alone. So this set already has these two carry brackets. You've seen them. So it means I'll write the carry brackets for writing them in the power set, okay, and then I write it the way it is like this. Okay, so this is a subset of this J. And then now start the combinations, 1 and 2. Okay, and then 1 and this other set. So it will just be 1 comma, and then the other set. Okay, and then I combine 2 with the other set. That will be 2. This is 3 and then 4 with the other set like that. Okay, so I don't have space there, but I can continue from there. Okay, so I've written this alone, this alone, this alone, and this combine this combine this. Okay, so what is remaining is the set itself. Okay, the set itself to just be 1, 2, and then I have 3, 4 there, like that. Okay, and then the last one will just be the empty set. Okay, so the power set of set J will contain this 1 alone, 2 alone, this set alone, 1 and 2, 1 and this set, 2 and this set, the set itself, and the empty set. That will be the full power set of what? Set J. Okay, and then the other one was find its cardinality. So cardinality is just the number of subsets. Okay, so the number of subsets is given by 2 to the power n, where this n is the number of elements in that set. Okay, the number of elements in that set. So in this set J, how many elements do we have? We have 1, 2, 3. So this whole thing is just one thing because it's in the set like that. Okay, so you don't count them separately like 3 and 4. No, this whole thing is 1. So we have 3 elements in this set J. So it will be 2 to the power 3, which will just be 2 multiplied by 2 multiplied by 2, which will give me what? 8. So the cardinality of this set J will just be what? 8. Right, we're done with that one. Let's look at C. Okay, so C, they're saying given the set A as this, given the set B as that, given the set C as that, and the universal set as this, find or list A complement intersection B complements. So here there are two ways. Okay, you can use the shortcut or you can go the long way. So the long way is you find the A complement okay? And then you also find the B complement, and then you intersect them to find your answer. Okay, but the short way is just use De Morgan's laws. We know that A complement intersection B complement is the same as A union B, and then the complement outside like that, okay, by the De Morgan's laws. So let's just find our A union B. So this is A, and then this is B. So A union B just combines all the elements from these sets, right? So I'm going to say my A union B, okay, the lowest is -3, can go to -1, then 0, 1, 2, 3, 4. Okay, so this is my A union what? B. Okay, that is my A union B. And then from there, okay, from there, I just want to find the complement of this set. That will be that will be my required set for this guy here. Okay. Okay, so what is the complement of this set? It means if I say this set and then complement, I'm going to find, okay, maybe I can put it in brackets like that. Okay, so this set and then complement, it means I'm listing all the elements that I cannot see in this set here. Okay, so the A complement and the A union B complement will be all the elements that are not seen in this set. Okay, so -4, I can't see it. -2, I can't see it. Okay, so I'm comparing this set with the universal set. So I can't see -4 here, I can't see -2. -1, I can see it, 0, I can see it, 1, I can see it, 2, 3, 4, okay. The other one that I cannot see is 5. Okay, so it means my A complement intersection B complement will just be the set, okay, -4, -2, and then 5. So this will be my set. But how did I find it? Okay, I used the De Morgan's laws. But there's no problem if you want to find the A complement, okay, and then find the B complement and then intersect them. You're still going to find this answer here. All right, so that is that. And then let's look at the second one. Okay, so the second one, they're saying verify that A union B intersection C is equals to A union B intersection A union what? C. So what we need to do here is just to list the A here. So the A is -3, -1, 1, and then 3. And then I'm going to say union, okay? B intersection C. So this is B and then this is C. So what elements are common there? Okay, what elements are common there? I can see that 0 and 1 are the ones that are common because we're getting the intersection of B and C. So 0, 0 and 1 is there. Even there, 0 and 1 is there. So I'm going to write 0 and 1 here is equals to, and then here, let's list A union B. So A union B, it is -3, -1, okay? 0, 1, 2, 3, and then 4. This is my A union B. Then I'm saying intersecting, okay, A union C. Okay, so let's combine the set A, this one, and the C. Okay, so we can see -3 is there. What else is there? Okay, -3 is there, and then -2, -1, and then 0, and then 1, and then 3. Okay, so this is my A union C. So I'm combining this set and this set. So the -3 is there, -2, -1, -1, and then 0, 1, and then the 3. Okay, so now let's find the union of what we have on the left. So this set here, union this set, what are we going to have? Okay, we're going to have -3, -1, 0, 1, and then what? 3. Okay, if I get the union. And then on the other side, I'm finding the intersection. So what elements are in this set and in that set? Okay, I can see -3 is there, -1, can see 0 is in both, 1 is in both, and then 3. Okay, so what do we end up with? What we have on the left-hand side here is the same that we can see on the right-hand side. So it means these things are equal. So it means we have proven that this and this are what? Are equal. So you write hence proved. Okay, so we are done with question 1A, B, and C. We move on to the next one, which is D. Let's then rationalize the denominator. Okay, so rationalizing the denominator, I've said countless times, it's just removing the square root, okay, from the denominator. So we have 2 minus root of 7 divided by the root of 7 minus 4. So we want to multiply this guy by the conjugate. Okay, so the conjugate is this same denominator, but we just change the sign in between. So it will be root of 7 plus 4 divided by root of 7 plus 4. Okay, and this here is what we call as a special one. So we are multiplying this whole thing with 1. So nothing changes basically. Okay, so let's multiply what we have on the top with what we have down there. So 2 multiplied by root of 7, I get 2 root of 7. 2 multiplied by 4, I get plus 8. And then I go to the minus root of 7. Minus root of 7 multiplied by root of 7. Okay, I'm just going to get minus 7. Why? Because this root and this root will cancel. Okay, and then this minus root of 7 multiplied by 4, I'm going to get minus 4 root of what? 7 divided by, okay, and then here I have expressions that are conjugates of each other. So whenever you have expressions that are conjugates of each other, you use a shortcut. So you just get the first term there, which is root of 7, you square it, and then you say minus, always put a minus, then you get the second one, which is 4, and then you square it. So what we're going to have here just be this square and this root will cancel, so I'll remain with 7 minus 4 squared is 16. So this will just be what? This will be minus 9, okay? So it means when I multiply this guy and this guy, I get what? Minus 9. So this one here, it means we have rationalized the denominator because I can no longer see the square root in the what? In the denominator. So we are done with the first one, okay? We are done with the first one. We look at the other one there. Okay, we look at the other one. So maybe there you can try to simplify what you have on top because they are common, right? Okay, so let's try to simplify. So this is 2 root of 7 and then um, minus 4 root of 7. That will give us minus 2 root of 7. And then 8 minus 7 is plus 1 divided by minus 9. Okay, like that. And then from there, maybe we can simplify it further. Okay, I can say this minus 9, okay, this minus 9 divided into this guy is going to give me minus 1 over 9. And then minus 9 divided there, it will be plus 2 root of 7, then divided by 9. So if you want, you can express your answer in this form. Okay, so that's what we have there. Okay, that's what we have there. All right, so let's look at the other question there. Okay, let's look at the other question. So the other question is we're trying to rationalize this guy here. Okay, so we use the same concepts that we are from doing. Okay, so 2, we have 2 root of 5 minus 3 root of 3 divided by, okay, I have root of 3 plus 3 root of 5. This is what I have. So I want to rationalize the denominator. So I'm just multiplying by the conjugate. So the conjugate is this same thing, but with a different sign there. So I'm going to say root of 3 minus 3 root of 5 divided by root of 3 minus 3 root of what? 5. Okay, and then from there we can just multiply. Okay, so let us multiply. So this is going to be equals to, so this will multiply with all this, and this will multiply with the whole this. So 2 root of 5 multiplied by the root of 3, I'm going to get 2 root of 15. Why? Because this root of 5 multiplied by the root of 3, okay, is the same as a big square root and then 5 multiplied by 3. That's why I'm getting this 15. And then we have that 2 outside. So 2 root of 5 multiplied by root of 3, I get 2 root of 15. Okay. Then 2 root of 5 multiplied by minus 3 root of 5. What am I going to get? Okay. The 2 and the 3 the 2 and the minus 3 will give me minus 6. Then this root of 5 multiplied by the root of 5 is going to give me 5. So this is just minus 30. So I'll write minus 30 there. Okay, so I'm done with this guy multiplying with this, and then I go to the second one, which is this. So this now, the minus 3 root of 3 multiplied by the root of 3, I'm going to get 3, okay? And then root of 3 multiplied by the root of 3 is minus 3 outside, and then there it would be 3. So this is minus 9. So I get minus 9 there. Okay, so I'll write minus 9. And then this minus root of 3 multiplied by minus 3 root of 5, okay, it will be minus 3 multiplied by minus 3, 9. And then root of 3 multiplied by root of 5, we said it was what? Root of 15. So there it will be plus 9. Okay, it will be plus 9 root of what? 15. Then divided by, okay? So what we have now in the denominator are just conjugates of each other. So what did I say? You get the first expression, root of 3, square it, and then minus. You get the second one, square it. So always put a minus here. Doesn't matter if there's a positive there or a minus, okay? As long as you're using this shortcut, we're just getting the first one, square it, you say minus, you get the second one, square it. Okay, so what are we going to get here? Here we're going to get 3. Here we're going to get a minus, this minus, and then this square root goes to the 3, goes to the root of 5. So when it goes to the 3, it becomes 9. Okay, because to be 3 squared, it will be 9. When it goes to the root of 5, it will just be 5. So this here will be 3 minus, what is 9 multiplied by 5? Okay, 9 multiplied by 5, that's 45. So this one will just be minus 43, like that. So that's what I'll write there. Okay, then I can simplify what I have on top. Okay, so on top we have 2 root of 15 plus 9 root of 15. So that one will give me what? It will give me plus 11 root of 15. And then minus 30 minus 9 to give me minus 39. And then I'm dividing all this by minus 43. Okay, so this here is my final answer. Okay, so we are done with D. Let's look at E. Okay, let's look at E. So E, we are just looking at rational numbers. Okay, so I want to express this guy here as a rational number. So E, the same express minus 4.213 with a bar on top in the form A over B, where this B is not equal to 0. Okay, so what are we going to do? We're going to say let X be equals to this same number bar. Okay, and then from there we want to move this decimal point here. We want to move it such that immediately after the decimal point we have the number with the bar there. Okay, so if a number has the bar there, it means it continues to repeat. So if, for example, I wrote 2.5 bar, it means this is the same as 2.55555 until wherever you will go. Okay, so this bar here means that this here continues to repeat. So this bar on 3 here means that we have 3, 3, 3, 3 until I don't know. Okay, so to avoid wasting space, mathematicians came up with a nice way to represent it. We just put the bar there. So I want to move this decimal point 1, 2. So just immediately after the decimal point there, I have the one that is repeating. Okay, so if I move it 1, 2, it means I'll multiply this X by what? 100. 100 has 2 zeros. So meaning I've moved 1, 2. Okay, so that 1, 2 represents 2 zeros. So it means my 100x will just be equals to minus 4, 2, 1, and then the point now is there. So it is 0.3 bar. Okay, and then from there, okay, I also want to move this point again. So such that after the decimal point, I have the one that is repeating again. Okay, but this number here, if I write it, okay, without the bar, it's the same as this until forever. Okay, so it means if this is my 100x, okay, if I move this point one more time like that, okay, it means I'll have to add a 0 to this 100. So it will be 1000x is equals to minus 421.3 bar. Okay, so what was the purpose of doing all this? The purpose, okay, the purpose is to have two numbers such that after the decimal point, okay, the purpose is to have two numbers such that after the decimal point, what is what is the color not changing? Okay, the purpose is to have two numbers such that after the decimal point here, okay, you can see that what I have there will just be, this should be a bar, it should just be the repeating part. So that when we subtract, this repeating part should disappear. Okay, that's our aim. When you subtract, this repeating part should be disappearing. Okay, so if the repeating part is not disappearing whenever you're doing this, just know that you are doing the wrong thing. So now subtract this bigger number from the smaller number. Okay, so we are going to say 1000 x minus 100 x. Okay, so the 1000 is equals to minus 4 213.3 bar is equals to the 100x is 421.3 bar. Okay, so I've forgotten a minus. Okay, so we are subtracting here, and this is minus minus. Okay, so we can just treat it as a positive if we want, because the signs are the same. So we're just going to say 3 bar minus 3 bar. Okay, it will be what? It will be 0. So this is the reason why we're doing all this here, is that when we come to subtract here, immediately after the decimal point, we should have 0. So if you don't get 0 here, just know that you're doing the wrong thing. And then it will be 3 minus 1 to be 2. And then here it will be 1 minus 2. It can't there, okay? So you borrow 1 from here, grade 7 mathematics. So you say 1 there and then 11. So 11 minus 2 to be 9, okay? 1 minus 4, at it can't, eh? So we borrow 1 from here. So it will be 3, then 11 there. Okay, so 11 minus 4, we're going to get 7. And then 3 minus nothing to just be 3. But this number is a negative number. Okay, so remember it's a negative number, so I need to add a negative there. Okay, and then here it will just be 1000 minus 100, it will be 900x. So what we have is 900x is equals to minus 3792. Okay, and then from there we can solve for x. Okay, so we're going to say x is equals to minus 3792 divided by 900. So we can see that 2 can go into there because it is ending with 2 and this is ending with 0. So how many times can 2 go into 3? Okay, 792. So you do your division, you are going to find 1896. Of course, it's a minus, and then 900, we divide it by 2, we're going to get what? We're going to get 450. Okay, so this is ending with 6, and this is ending with 0. So it can be divisible by 2 again. So we divide this number again by 2. Okay, so the 1869, okay, we divide it by 2. It's going to what? Okay, I wrote the wrong number. So 1896 divided by 2, I'm going to get 948 divided by, okay, this 450 divided by 2, what is it going to give us? Okay, it's going to give me 225. Okay, so now, is there a number that can go into that number? Okay, and the 225 without leaving a remainder? Okay, we can try 3. So 3 into 948. Okay, it's going to there minus 316 times divided by, okay, and then the 225 divided by 3 is just 75. Okay, so can 3 go into 75? Yes. Can it go into 316? No. Okay, so here there's no number that can go into this one and this one without leaving a remainder. So it means we leave it here. Okay, minus 316 divided by what? 75. All right, so that's all for question 1. In the next video, we are going to solve question what? 2. All right.